Good afternoon.
Good afternoon. Hi, everyone. I hope you all had a good lunch break. I'm going to get us started in just a sec. I am just making sure I'm letting everyone in here. Yes, we're in our, this is your last class today, isn't it, y'all? So I'm going to look forward to, then you get to relax. It's going to be great. Look. All right, I think we are ready. So if you haven't yet, y'all, you're free to go to Google Classroom and make a copy of today's slides. They are already linked. Today we're on day 4 of our pre-calculus lessons, y'all. So let's go ahead and jump into our check-in question to see who we have here, who we're missing, so forth. Let's see. Okay, so this is always a controversial question. If it was raining meatballs, would you eat them, is the question. So think about that. If it was raining meatballs, would you eat them? Let's see what we got. We got so far a resounding no. That's dirty. Okay. Imagine the meatballs are clean. There's still a resounding no. What if they're clean though? There's no back. It hasn't hit a tree or nothing. We got no, not that desperate, not at all. I did have a few yeses, I swear, in my other classes. Everyone's saying no though. Don't be ashamed. To be honest, if you were to when I said yes, I said as long as they were clean though. Like I know 100% they're clean. Said no, I wouldn't. That sounds nasty, but I don't know. Oh gosh. Y'all are hilarious. We got if Gordy, okay, good. We got if Gordon Ramsay made them, then yes. They have to be extremely like delicious. Okay, then we have, but they're gonna fall on the ground eventually. That's true, but before, let's say you go outside with your bowl of spaghetti noodles and then you just get some fresh, clean meatballs that are already seasoned. We got, I don't really like meatballs that much. I mean, they're good, but I'm not eating them out of the sky. I mean, I probably get a bowl and collect some. Oops. And then why would meatballs even fall from the sky? That's just unnatural. No, I'm vegetarian and never liked them, to be honest. Yeah, I actually don't eat real meatballs. So for us vegetarians, imagine that there's a big kind of substitute of it falling down from the sky. And by the way, back when I was a meat eater, I did love meatballs actually. Someone in another class says it depends if they're seasoned. I'm like, what? So yeah, we got ew, no. Oh my gosh, I have to make sure I check who's here. That's hilarious. We got Cloudy with a chance of meatballs. Who?
I feel bad for vegans if
Um,
they went outside and it's a bunch of meatballs raining down.
yeah, that would be kind of like, what in the world is happening? And then everybody would have to cover, like, nobody wants to get hit with some meatballs. And I'm imagining these meatballs have spaghetti sauce on them or something. So that makes it even uh, more messy to even get all over you. That's right. Oh, I'm sorry. Let me check out what you have. Okay. I'm so sorry, y'all. I was so into this question. So let me go ahead and see who we have. So please correct me if I'm wrong, but I think I'm missing Jalen. I am missing Denise. I am missing, am I missing Miles? I'm sorry, Miles, if you did answer the check-in. Yeah, so I am missing Miles. Oh, Denise, you're here. My bad. Let me go ahead and mark you here. Okay, so I'm missing Miles. I'm missing Jairo. I'm missing Jalen. Am I missing Alexander? Alexander, if you're here, let us know. Oh, actually, we just got Jalen right now. Yes. I'm missing Carlos, Kyla. Leon, Marcella, Sincere, Celia. Let me know if that's accurate. So let me go ahead and repeat who I'm missing, y'all. So a final round just to make sure I got this right. I am missing Miles, Jairel, Alexander, Carlos, Kyla, Leon, Marcella, Sincere, and Celia. Actually, we just got Marcella, y'all. So let me fix that. Yes. All right, cool. And if you're here, please just let me know. Thank you so much for that interesting check-in about falling meatballs from the sky and if you would eat them. Okay. Oh my goodness. So now we're thinking about the physics of it all. Someone's like, imagine the meatball falling from the sky at whatever speed. That's like dangerous. It's like standing on top of Eiffel Tower or Statue of Liberty and dropping a quarter. So imagining those scenarios. Another student, I did say, okay, imagine the meatballs are clean and they're falling. But then another student was like, well, what about air pollution? I was like, okay, they kind of made a good point there. So yeah, thank you so much, y'all, for sharing. Let me jump us into our agenda for today. That was fun. Okay. We just took attendance. We're going to have an introduction to the unit circle. We've been looking at the unit circle, like y'all did a notice and wonder, but we're going to have a formal introduction today. We have a mini, so it's a small, like 4 to 5 slides, a mini group Desmos. So today we do have some group stuff, group interaction. It's very small. Then we have an exit question. Lastly, the next asynchronous assignment is going to be due on Friday, which is tomorrow midnight. And this asynchronous assignment is pretty short. There's like 3 questions on there, and it's basically just asking you to kind of review what you know about a radian and what it is based on yesterday's lesson. So that is what we have happening for us here today. Let me know if there's any questions from anyone here. I'll pause to see if we got questions or any other additions. Okay, cool. It looks like we're good. So let's go to our little recap, y'all. So yesterday we finished up our group Desmos and we talked about how 260 degrees is actually equivalent to 2 pi radians on a circle. From that, we developed these equalities. The fact that 2 pi is equal to 360, and you're able to reduce it into this red formula. This red formula serves as an expression, and these are basically called two ratios to help us convert between radians and degrees and vice versa. So that is where we left off yesterday. And I actually love this chart right here. Sometimes some people get confused. Like, I don't know if I need to multiply by 180 over pi or do I multiply by pi over 180, right? Because there's an or. So it's either or, right? So I like this chart. So if you're going from radians to degrees, you multiply by 180 over pi. Whereas if you're going from degrees to radian, you multiply by pi over 180. So there's like a direct kind of little chart for you to reference in case you're getting confused and stuck on what to multiply by. The next synthesis of our big ideas was this first part I already mentioned. We got this pi radians equals 180. And the second part, the second 2 bullets down here, we convert radians to degrees by multiplying by 180 over pi. And you convert degrees to radians by multiplying by the opposite, pi over 180. So that was a little synthesis of the stuff we did, we practiced on yesterday. Okay, welcome, welcome. If you just came in, I see you. Let me go ahead and fix up our attendance. I'm glad that we have more of us coming in. I appreciate it. All right. So let me know if anyone has questions about these big ideas. Otherwise, oh wait, I mean, we're not done yet on this big ideas because on the next slide, I basically have for you screenshots of the 2 examples that video showed you. In addition, we also had y'all practice. Remember, y'all were making little, you're trying your best, and then I gave some feedback. That's also in addition to what we did yesterday when we got this practice in. So that was a little recap. Let me know if there's any questions on the recap or if anything comes up for you later. Awesome. Oh, wait, there's something in the chat. Let's see. I am responding to your private message. Sorry if it's in all caps. I apologize. All right, y'all. So let's head on to what we're doing today and that mini group work that we're going to be doing. So the unit circle is where we're going to focus on now. The learning target is I can explain the components of the unit circle. So let's go ahead and dive into this new lesson and this learning target. Take a moment to read that learning target. So at the end of class, you can process and see whether or not you've met that learning target. All right, y'all. Okay, so here what I have for you is our unit circle. Remember, this looks scary. We first saw it yesterday, no, 2 days ago, I believe. And y'all did a notice and wonder on it. And it looks scary because there's like so much stuff on it. But essentially what it is you have degrees. What in the world? You have degrees. They start at 0. And you keep increasing the amount of degrees and go around the circle until you hit 360, which is equivalent to 2 pi. Yesterday, we learned about what these red colored numbers represent, the ones with the pi in them. These are the equivalent radian measures. So now we know what these parts mean. The ones in red, y'all. Isn't that great? So we know what they mean, but now let's talk about how we create angles on a unit circle. This little visual could kind of help us understand how to make those angles. But I'm going to be over here doing some little bullet points. So first, the initial side, like how we create angles is we start with the initial side on the positive x-axis. And on the unit circle, that looks like, let me delete this now so I can draw this initial side on here so you know what I mean. I'm going to use a straight line tool. So I am right now drawing the initial side on my unit circle. Boom. Okay, that's my initial side. It's on the positive x-axis. Next thing, the terminal side, so you can see here terminal side, is the ray that rotates about its vertex and to measure the angles on the unit circle. So let me show you what that looks like on a unit circle. Let me get back up my tools. So I am now creating my terminal side. That's the one you see right here. See it? It's like I'm just lifting it and closing it. So it says you rotate it about and you measure angles. So for example, if I want to make a 30-degree angle, there's where I'm going to place my terminal side at that first coordinate point, which corresponds to 30 degrees, aka pi over 6. Or let's say I want to make a 60-degree angle. I'm going to rotate my terminal side up here, 60-degree angle, aka pi over 3. I can also do more than just a 90-degree angle. I could go, let's say 120 degrees over here, which is AKA 2 pi over 3, and so forth. I could even make a flat line at 180, and I could keep going around. This is a 210-degree angle, 225, and so forth. So that is how we rotate along. And notice how I'm moving this terminal side counterclockwise. What I mean when I say counterclockwise is kind of opposite the way a clock moves is how I'm moving this. When we move the terminal side opposite the direction a clock moves, we are able to make positive angles. So that's my next bullet right here. You move the terminal side counterclockwise for positive angles. So this right here is going to be a positive angle. This is a positive angle, but you actually can make negative angles, everyone, on a unit circle. You can move the terminal side clockwise. That means the way a clock moves for negative angles. How that would look like is, I guess I'll use this one down here, and I'm going to use, I don't know, yeah, I'll just use red again. So let's say this is my terminal side. So if I start here on my initial side and then I move backwards, let's say I do that movement, That means this angle, whatever angle that is, and I don't know, I'm gonna just say that's a negative 45-degree angle. Because I moved backwards, aka moving in the direction that a clock does, that will give me a negative angle. And sorry for all the AKAs, but yeah. So that is just a general way in how the unit circle works and how we draw angles on them. Let me know if anyone has questions about this here slide. I'll pause for that. If not, we'll take a look at a little bit more about how we can make angles on a unit circle. All right, cool. I don't see any questions, so let us go, everyone. Let me clear my drawings and let's go on to the next slide. I am on slide 9 for those on my slides. All right, y'all. So let's talk about the different kinds of angles you can create on the unit circle. You can actually create any angle. So as I mentioned before, when you move clockwise, you make negative angles. If you move counterclockwise, that's how you make positive angles. But, and this is another negative angle, but you can even go around more than once to make angles that are even larger than 360 degrees. Take a look. When you spiral around more than once, you can make like a 570-degree angle. Now, why? Let's see. So there are applications, like for example, when a wheel is rotating, and it's convenient for us to actually just expand our definition of an angle to be more than 360, because we want to model real world situations where something keeps rolling more and more than just 300, more than just once, right? So that means measures can be any number of degrees, including moving in positive directions or even negative directions. So there's just a little overview on how to make those angles and what they could possibly look like. Let's see if there's any questions on this portion. All right, awesome. Cool, let us jump into the thing that's going to prep us for our group work here today, y'all. So thank you so much for, taking a look at what is a unit circle and all that. I kind of wish I added in a little Padlet there so we could check in on our understanding. But let's go ahead and jump into this next portion of today. We have an essential question to think about that's going to prep us for our group work. Unit circle and waves. Y'all remember at the beginning, like the first day, we talked about why trig was important in the real world, and I gave you all a bunch of different waves. So we're gonna think about this essential question. How in the world is a unit circle connected to functions that have waves in them? That's what we're gonna focus on thinking about today, and that's what our group work is gonna center on, this essential question. So let me have you all look at the question, think about it a bit, and then we're going to transition into the next slides. All right, everyone, let us begin. So a little refresher, I had shown you all this on day one. The fact that many things in the world can be modeled with trigonometric functions such as waves, and basically anything that has a repetitive vibration around us has some type of graph showing the movement of airwaves it creates. So for example, think of music notes or any sound. So when you hear sound in the air, what you're actually hearing is air molecules getting compressed close together and then far apart. And through that, they make sound waves that your ear interprets as sounds. It is wild, and it's also what our our next mini final is going to center on. These waves are actually modeled by a trig function, and specifically this one down here is called a sine function. We're going to learn a little bit more about sine once we get a little bit more tools. Now moving on to slide number 12. Y'all, back to our central question. Cool. So we know that there's some things like sound that can be modeled by waves. There's many other things that can be modeled by waves. But exactly how in the world is a unit circle such as this connected to something like a sine wave? What connections can we make? So think about that. Look at this. Look at these two visuals. Try to make what kind of visual connection can we see? That's what's going to be the main discussion and the main juice in your groups today. Oh, there's something in the chat. Sorry. Um, so someone asked, do we really need a copy? Can't we just watch you? Actually, I'm leaving that up to you. So for example, I'm not collecting notes. So because most of us are like 11th and 12th grade, I'm gonna leave it up to you. So I give the option for y'all to make a copy so that you can, if you'd like, make little annotations on the slide as you follow along. It is a good practice, for example, once you hit college, but totally up to you for that question on do we need a copy? Up to you. Yeah, since I won't be collecting it. So you can hold yourself accountable to that. Um, and then I have something in my chat that says the fractions. Okay, so someone is already thinking about a connection between these two, and they mentioned something about the fractions as a connection. That could be totally something to bring up in the group as well. Awesome. Okay, y'all. So think about this, and let's go ahead and transition here today into our groups. So it's going to be a short group Desmos, and it's a participation quiz. I put in quiz, but you know what it is, just participation. You get into your groups. I should see screen sharing, interaction, both if you want to do it out loud or you could do it in the chat, whatever works. You can unmute or you could just use the chat for your interaction and just generally checking with each other for understanding. It's going to be about 10-ish minutes. Make sure everyone's name is written on the Desmos for credit. And again, here's the prompt. How is a unit circle connected to functions with waves? If your group is stuck, just go ahead and jot down notices and wonders or anything that comes out for y'all. The Desmos link should be on Google Classroom. So I don't think I actually put it. So I'm going to go ahead and put that before we actually jump into that. So give me a second, everyone. I go to my teacher Desmo. So again, only one person is going to need to log in for their group. And then you're just going to make sure that everyone's name is on the, on the Desmos itself. So let me copy. And I'm going to go to Classroom. Make sure you all have this. Group Desmos. Today is the 15th. There we go. Finally posted. So if you have your Google Classroom open, just refresh your page. So again, this is going to be a group thing. And here are again the directions. One person in your group is going to go to Google Classroom, share their screen, and y'all will complete the Desmos activity together as you investigate this connection between unit circle and waves. What do we notice? Unfortunately, no, I'm just going to have an auto assign for the group. So there's a question, do we pick groups? So there's only going to be an auto assign. There could be, if you're logged in with your email, it kind of auto assigns you. I don't know how to do the picking groups thing, to be quite honest with you. Okay, thank you, thank you. All right, y'all. So any other questions before I go ahead and stop my share so I could put us into our breakout rooms? Like I said, it'll try its best to keep the same groups as before, but usually when someone's absent, some rearrangement happens. Again, I'll be popping into every group just to make sure that we're able to screen share and things like that. Or any issues coming up, let me know. Okay, so let's see. All right, so some folks are already assigned to some breakout rooms and some are not. So, just give me a sec as I go ahead and start to balance groups. All right, let's see how these work, y'all. Actually, no. You gotta move some groups are too small. So give me a sec. All right, let's see, y'all. I'm gonna go ahead and open up the rooms. Go ahead and join your group. You should see an invite now. Remember the directions. Go to Google Classroom. Click on the link. Make sure everyone's name is on there. Click your group, y'all. Join your group. Awesome, awesome. Let's see, Gabriel, Zion, Risha, Kyla. Do y'all see an invite for a breakout room? All right, y'all. Make sure you're able to join. If anything comes up, let me know. I'm gonna start checking in on groups, y'all.
I'm also on the phone, but I guess
I mean,
I
I
can
could
do
share.
it.
I could
Oh, you
share.
can do it?
Yeah.
Okay.
Hold on. I'm Sedana.
Hey, y'all. I'm just trying to see if. Okay, great. Y'all were figuring out who could screen share. Awesome. I'll just be popping in and out, so I'll be coming back. Hi, group. Who is gonna be the screen share here? Oh, oh wait. What were y'all discussing right now? I see something in the chat as well. No one can share their screens. So Denise, Gerardo, Tori, Brenda, is anyone able to share their screen in this group here today? Okay, so it won't let you, Denise. Okay, how about you? Oh, okay, Gerardo's on phone. Okay, so let's see. So let me go ahead. Okay, cool. So right now, no one can share their screen. Let me go ahead and check in other groups. Let's see how many others are having this issue. I'll be back soon so I can kind of see how we can make an adjustment. All right, y'all. So I'll be back. This is group 12. So I'll be back to group 12, y'all. Give me a sec to check in on other groups.
Well, I think the waves can be like going counterclockwise and then.
Hey, group. Ruben, Sam, Gabe. Is anyone able to share their screen in this group? So Ruben can't. How about Sam or Gabe? Sam says me neither. Okay, and then let me know, Gabe, but let me go ahead and check in on other groups, all right? Give me a sec. Okay, so I'm gonna be coming back to this group, okay? So give me one sec and just make sure y'all know where to be at when it comes to the the whatchamacallit, the, you know, the stuff. So I'm gonna check in on other groups, and I'll be back right now. Hey groups, I did add a few extra folks here. If we could make sure their names are in the first page, that would be so great. Just checking in on all the groups here.
All right, who else is here?
She said something sound and then something else. I didn't get it.
And then hi group, sorry to interrupt. Sorry, y'all, we're having a good discussion. I did add a few more students into this group. So if y'all,
Oh,
yeah, if y'all can add their name to the first page, and then I'll be actually working in with one group who can't screen share. So yeah, I'll leave y'all
All
to.
right, but wait. Real
okay.
quick.
And how-
That's how you spell your name, right, Risha?
Yeah, that's how I spell my name.
Okay.
All right, everyone, I am back. So what I'm gonna do is I'm gonna just be with this group because I don't want the other groups to be too large. So I'm gonna go ahead and project my screen, and I'm gonna go ahead and just pretend to be a student, and y'all are just gonna guide me. So I won't be really kind of helping. Y'all can just, you know, y'all can work on this, and I'll just be like kind of typing out your work for you as we move along. And then I'll be on my phone checking in on how the other groups are doing. So I'm gonna put my name to go. And let us decide our role. So someone could be the facilitator. That means kind of just leading the group along or asking any clarifying questions. And you could do this in the chat or not. So we need a facilitator. I guess I'm recorder since I'm the typer. I'll just put my name, sorry, Sagano. And then we need a timekeeper to just make sure we're on time. I like to speed things up if we're taking too long or to move on. And then team captain, which makes sure you're checking with everyone. Make sure that you're asking each other questions. So let's see. How about you put in the chat what role you want, and we'll just do it like that. So what role do we want? All right, we got Ruben's gonna be timekeeper. Sam doesn't mind. Okay, so Sam, if you don't mind, I'll put you as facilitator. Ruben will be timekeeper. And then that means Gabe, you'll be our team captain. Gabriel, sorry if you don't like Gabe as a nickname, so you can just put Gabriel. All right, awesome. I'm gonna hit submit now. Let me move my tab out the way. There we go. So I'm gonna hit next. Okay, y'all. So now, just as a group, just start putting ideas out there and even in the chat. So it looks like y'all are comfortable in the chat. So let's do that. So how do you think a unit circle can help us model something like a wave? Just go ahead and start putting any ideas in the chat, and I'll just go ahead and put them onto the, on the screen here. Ruben, Sam, or Gabriel, any ideas that are coming up for you on how this circle here can create something like a wave? All right, thank you. I see, sorry if you were typing. So I went ahead and just put the question in there. So Sam says the edge of the circle is round. So maybe if you use the circle to measure the waves, I like that. So it's kind of like you're using something on the circle as a measurement to perhaps measure the waves. So I like that. So it's kind of like a little wonder there with a connection. Let me go ahead and put that in for our, oops, I guess it won't let me actually copy and paste. So I'm gonna just write it. So the edge of the circle is round. So maybe if you use the circle to measure the waves, question mark. Anything else like Ruben or Gabriel, if anything is coming up for you, anything else that we can add to this, or do you feel like we're set? Okay, Ruben, and don't know. Do you agree with what we have here, that maybe that perhaps is a good like kind of notice or a wonder there? Because if we don't know, we could just do a notice or wonder, and that's totally fine. All right, so Ruben, we good. I'll send you a private message, Gabriel, if you're there with us. All right, cool. So let's go ahead and stick with what Sam said. I'm going to go ahead and enter this. And we could also take a look at what other groups are saying. So we have, oh man, I didn't even anonymize the names. Let me do that now. There we go. So we have a unit circle models waves because the degree of the number that may cause the sound on the line. Okay, so they're making some connection with the degrees of the number and may cause the sound. Lines are going through both have fractions with pi. So they both notice that the pi's are coming up through both. So they're just in general making some light connections. So it's interesting to see what everyone else is thinking. Let's go ahead and move on to the next part. Okay, y'all, let's go ahead and investigate. And I linked up a tool for everyone. It says, using this tool, we're able to create a sign function. How can you just your team describe what's happening now when you open up the tool? So let's first look at the tool. Let's see what this is. Okay, look at this, y'all. This is pretty cool. So this right here is angle. Right now it's at 0 degrees, but if I increase my angle, let's see what starts to happen. So what do you think is happening here? Take a look. See, a wave is forming. I'll try to move it like slowly so y'all can see what's happening. It's a nice little visual tool so you could see how a unit circle or any circle is kind of creating a wave there. So there's our wave, and we could keep going. So it keeps going around and around, and it continues to make this wave. So it stops kind of there. So let me just go ahead and go back so we can start to pay attention like on what we think is actually happening when it comes to the unit circle and wave. So it starts off at 0. And then as we increase the angle, like what is that thing we're measuring, I guess, as we increase this angle? Like what is getting mapped out when we're making these waves is what we're thinking about. Or any patterns and connections you can make with this as well is also super valid. So I'm going to also put this in the chat so you could each kind of explore this and check it out on your own. I'm going to put this in the chat for us all. If you'd like to play around with that and kind of just take your time. So let me give you a bit to explore, a minute, and then I'll ask Sam and you, Ruben, to share with me like what do you notice now after we've used the tool? How can you describe what's happening now that we've explored the tool? So again, play around with the tool, and now try to again think about how a circle is making a wave? Like, what are you making? What connections are we making now? Sorry for all my words, but yeah. So let's play around with the tool, take a minute, and then take this minute to perhaps start typing out your thoughts. And it could be a notice or wonder too if you're stuck. So if you wanna say, I don't know, I wanna push you to at least put a notice or wonder. So take a minute. All right. So this is for you, Sam and Ruben. What do y'all think? Go ahead and put it in the chat, and I'll go ahead and transfer that into the little slot here to see what we think is happening now with how a circle could be creating a wave. All right, take a look. So we got some juicy ideas there. Let's see. So it looks like the line grows as you go around the unit circle. So you could use the length of the outside of the circle to find the length of the wave. Okay, that is interesting. And then we have from Ruben, maybe each time the line goes around the circle, it creates a wave. Ooh, I like both of those things. I'm gonna go ahead and put them both in here. So I'm gonna try my best to, I can't copy and paste. Let me try it. Let me see. Oh, I can. Wow, I'm BSing here. So here we go. I can copy and paste. I guess I just was unsuccessful the other time. So there's both of your feedbacks. So yeah, I noticed that there is a connection to Sam as it goes around and around, that line just grows and keeps increasing, just like the degrees or whatever is increasing. And I like that each time it goes around the circle, it makes like one wave. I love that. Let's put that in. And we could see so far for those groups that were here already, what they had attained. So we have the higher number, the bigger the curve is what's another group noticed. The higher number, the more waves created. Oh, so I guess like the higher each time we ran around, something similar to what Ryu said, Ruben, the more waves we got. We also have another group that says when exploring the tool, one can see that when moving the bar from the left to the right, it creates a wave. Whoa, due to the triangle making some sort of degree. So that's interesting. So cool. It's nice to see everyone's thoughts here. Let's go ahead and transition us into the next slide. Okay, y'all. So now that we've had this exploration, I'm bringing y'all back to the prompt. How we're being asked to answer the prompt. So then, how is a unit circle connected to functions with waves? Is just the general question. So how would we answer that? Like I see that y'all put those two things there in the chat, but if you want to kind of, you can just let me know in the chat, like, oh, let's just keep what we just said in the chat, or if there's anything new that you thought of, you could go ahead and add that. So let me just rephrase that. Sorry, I'm getting a remind text. Okay, so actually someone's having issues where they're stuck in the breakout room, y'all. So Sam and Ruben, basically this is answering, it could be the same thing you all put from before, like where y'all notice as it goes around and makes more waves and so forth. Let me just go ahead because I got to take care of that issue. The next thing, I don't know if we'll have time to get to it, but at least let's read it. So compare the following functions. How are they similar? How are they different? So take a look. This is a wave. This is like a weird, funky looking wave. There's some other funky looking wave. And then there's like a weird repeating kind of line thing. You were asked to like think about what's similar and what's different between these two. That was going to be the last question. So just keep this in mind because I'm going to go ahead and transition out so I could let that student in. I know it's so messy, but I'm really glad that we got to do this. Thank you, Sam, Ruben. Thank you, Gabriel. I'm going to go ahead and check in on other groups and I'll be bring everyone back super fast. All right. Thanks, y'all. And you will both, sorry, you three will be getting your credit. Thank you so much. I'll be back. So just chill for a bit. Hey group, how's it going? Did we finish?
Yeah.
Oh, okay. I was
Yeah,
with,
we done.
okay, great. That's awesome. I was with a group and I was unable to get out of the breakout room. I'm gonna go ahead and start to bring everyone back. So I'm gonna close all the rooms. See you soon, y'all in the main room. Hello, main room. I am just making sure I'm letting in everybody that I wasn't able to let in. Hi, Tori. So I just saw your message. Thank you for sending me. No, you will not be. Don't worry. You're all good. Welcome, Tori. I'm going to go ahead and synthesize all the Desmo stuff. Welcome back, everyone. Let me share my screen so I could take us off. I was working with a group, so that's why you probably didn't see me popping in, but I still saw some amazing stuff happening in your groups. Please, again, make sure all your name is written down there for credit and so forth. Let's talk about what we got. Okay, so let's see. First off, slide number 2. These are the connections that our 4 different groups noticed between a circle and making waves. So we have the waves can go clockwise and counterclockwise to create waves instead of going in a circle. And then it says there's a lot of angles in the waves that could be connected with these angles right here. You see those angles happening right here on the circle. So I 100% agree with Maria's group. Grace's group says that lines are going through both. Not sure about lines. I don't know if you mean like these lines, like the X and the Y axis. And then it says both have fractions with pi. So there's another group that is noticing that connection with the radian and this X axis where they both have pi. Henri's group says a unicircle model waves because of the degree number may cause the sound of the line. So they're thinking there's a connection between these degrees and sound. Lastly, the edge of the circle is round. So maybe if you use the circle to measure the wave, so kind of using the circle to measure something in the wave. I really like Vivian's contribution there. On part 3, y'all were asked to go ahead and investigate this amazing tool that kind of visually shows you how a unit circle actually is making waves. So it's pretty cool. But our goal, and basically the hard part, is how do we kind of elaborate what's actually happening here? Like what is being measured? That's why I really liked Vivian's contribution there. So what exactly are we measuring when it comes to a circle and the fact that we're making these waves? So that was juicy. And so you all can take a look at this, but the ones I wanted to definitely point out is Grace's comment where it said the higher the number, the bigger the curve. Let's go ahead and see if that's true again. So higher the number. So for example, the green circle, right? It's all the way up at the top of the circle, see? And it makes kind of like a maximum on the wave. Then it goes down, 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 and it gets kind of like negative. Goes back around, and then again it goes it goes to a high point on the circle, and notice that it makes another maximum and down. So I agree with Grace's, sorry, I was with the group. So I agree with Grace's contribution there, that the higher the number, it's kind of like the wave is at a high point. And let's see, another group mentioned something about triangles, using triangles to somehow create the waves. And this one, it says, as you go around the circle, you can see the length outside of the circle, maybe find the wave. And I like this one down here. Maybe each time the line goes around the circle, it creates a wave. So each time it goes around once, you get one wave and you keep getting more. So let's go ahead and bring everyone back to our slides. So thank you so much, y'all, for working in your groups. And I saw so many exciting things, but we're gonna go ahead and transition. So we're gonna know the connection between waves and unit circles next week in our class. So just keep this investigation in mind. Y'all are amazing. Let's go ahead and jump into our checkout right now. So we just did an investigation. There's probably a lot of questions in your mind. What is a question that you have right now? Go ahead and put that in the chat, and it could be about anything. Put it in the chat and we'll go ahead and close. All right, will we ever have to memorize a unit circle or parts of it? You're lucky you're not part of my high school. They made us memorize that unit circle. There was no point to that, because it's like, what's the point of memorizing something we don't understand? So no, Tori, you will not be asked to memorize that. Good thing you weren't part of my high school. Does the squiggly line represent the circle? Is a question. So but just drawn like that? That's a good one. We're gonna know exactly what that squiggly wave represents. And then we got Danny agreeing with the question. I'm still curious about what to do with all the numbers and the circles stand for. Like what is that, right? Yes, we're gonna be able to take next week. None I could think of right now. Can the wave go infinite? Says a question. Yes, as long as you could keep going around in a circle forever, your wave will be infinite. What are the most important parts of the unit circle is a good question. How would you have connect the unit circle and wavelength? Because it still confuses me. Don't worry if you're still confused about that, because we're going to hold on to that confusion. It's going to lead us into next week's lesson. So that is okay if you're confused about that connection, because we're still investigating it. Okay, y'all. Y'all are amazing. That is in our last minute. And then can we use the squiggly line to convert degrees? You actually can. That's a good question. That's very deep, actually. Okay, y'all. Y'all are amazing. Have a great day. Yay. Bye, y'all.
All right, see you
All
later.
right then.
See y'all.
Bye.
Bye. Y'all are awesome.
Bye.
Bye.